Welcome back, viewers. Is it possible to find the value of x when you've been given 1 raised to power x is equals to 3? Now, in this case, remember from the Euler's equation, when you are given exponential I theta is given as cos theta plus I sin theta. Now, when we have a complete cycle, that is when theta is 2 pi. Remember, 2 pi is 360 degrees. That is a complete cycle. So when theta is 2 pi, what will be our Euler's equation? Where there is theta, we will substitute with 2 pi. So anywhere you see theta, let us substitute with the 2 pi. So here we'll have 2 pi I is equals to cos 2 pi plus I sin 2 pi. And remember, 2 pi is a complete cycles. So when you have n number of cycles, when you have n cycles, then what will that imply? It will imply in our equation here, we will now have exponential 2 pi ni is equals to cos 2n pi plus sin 2n pi. Now start with the first case here. What is this? Remember, cos 2 pi is the same as 1. Then it is plus I. Then sin 2 pi is 0. So 1 plus 0 I times 0 is 0. You'll remain with 1 plus 0, which is 1. So it therefore means when n is any integer, for the n number of cycles, when n is any integer, for instance, when n is 1, we will get, so when you have n to be equals to 1, when n is 1, we'll remain with exponential 2 pi I is equals to cos 2 pi plus I sin 2 pi, which we've already found to be 1. When n is 2 in that order, when n is equals to 2, then our equation will be what? Where there is n, we will substitute by 2. So 2 times 2, there we will have 4. Then when n is 2, we'll have there 2 times 2 will be 4. When n is 2, we'll get 2 times 2 will be 4. So remember, cos 4 pi is also 1. Then plus I sin 4 pi is 0. So you still get 1. Again, when n is equals to 3, what will we have? We will have, where there is n, if we put 3, it is 3, going to be 3. N is 3, so 3 times 2 is 6. N is 3. 3 times 2 is 6. N is 3. 3 times 2 is 6. So we'll have cos 6 pi is what? Cos 6 pi is 1. Then it is plus I. Sin 6 pi is 0. You still get 1. So if you continue with the same scenario, when n is an integer, then generally we have exponential 2 pi I, which is cos 2 pi n pi plus I sin 2n pi will be what? Will be 1 plus I times 0 when n is any integer, as we have spelled out, and that is equals to what? And that is equals to 1. So here we can see exponential 2 pi ni is equals to what? Is equals to 1. Now, when we go back to our equation, we were given 1 raised to power x is equals to 3. So when we go back there, we have 1 raised to power x is equals to 3. And what is 1? We found the general solution of 1 according to Euler's equation. 1 is the same as exponential 2 pi ni. So where there is 1, we will substitute with exponential 2 pi ni. So you make that substitution there. Then you use the laws of indices. So when you use the laws of indices, the power outside will multiply the power inside. So there we'll have what? We'll have exponential raised to power 2 pi ni times the x, which is outside, like that, to be equals to 3. Laws of indices, the power x will multiply the power inside. Now, For you to get x is in the power, for you to get unknown in power, then introduce the log. Because we have an exponential function, we introduce the natural log, ln, with an Aperian logarithm on both sides. So if you introduce ln on both sides, what will you have? Ln of exponential 2 pi I x is equals to ln of 3. Just to get x, the power here, 2 pi n I x, because we have the log, will becomes the coefficient of the log. Then there just remain ln of e. And what is ln of e? ln of e is 1. So what will we get? ln of exponential function is 1. We will remain with 2 pi n I x to be equals to ln of 3. So how do we get x? So we divide both sides with the coefficient of x, meaning we divide both sides by the coefficient of x here is 2 pi n I. So if we divide both sides of the equation by 2 pi n I, divide both sides of the equation by 2 pi n I, then we'll get what? This side 2 pi n I, on the left hand side 2 pi n I will go with 2 pi n I, then the other side of the equation will remain with x equals to ln of 3 plus 2 pi n I. And that is how to solve that kind of problem. And remember again, you can make it more general. Remember 3, if you want to make it more general, remember 3 is also the same as 3 times 1. Are you seeing that? 3 times 1. So the moment you are going to introduce the natural log ln of 3 here, ln of 3 can as well be general. That is going to be in bracket ln of 3 times 1. ln of 3 times 1. So if you take the log inside the bracket, what will you get? ln of 3 times 1, because we are looking for a general solution. So what happens here? 1 is the same as exponential 2 pi n I. So where there is 1, we are going to put exponential 2 pi n I. So when the log goes inside, in the numerator, we are going to have ln of 3, then multiplication sign will change to, the multiplication sign will change to what? To addition, ln of exponential 2 pi n I. Then it is over what? 2 pi n I. So from here, on the numerator here, you can see in the numerator, ln of exponential, meaning the power of this exponential function will become the coefficient. So when it becomes the coefficient, we'll just remain with ln of e. And you know ln of exponential function is what? The natural log of e is 1. So this one will be the general solution, where n is any integer. So we've seen that the general solution of x is what? ln of 3 over 2 pi nx, then it is plus 2 pi ni over 2 pi ni, because 2 pi ni is a common denominator. So this is what you have. So remember, 2 pi ni over 2 pi ni, the whole of it will be what? Will be 1. So this is the general solution of x. If you multiply both numerator and denominator by I, ln of 3, then over, if you multiply by I. So what is I? I times I in the denominator, there will be what? That one will be equals to, in the numerator we have I, ln of 3 over, I times I is I squared. So that will be negative. So you'll have negative 2 pi n. Negative 2 pi n. Then everything is plus 1. So if you interchange for the positive to start, then what will we get? X to be equals to what? Positive 1 to start. So we will have 1 at anywhere. So negative is in front there. 1 minus I ln of 3 over 2 pi n. Where n is an integer. Ladies and gentlemen, that is how to solve for x in the given problem when 1 raised to power x is equals to 3, then the solution of x is 1 minus I ln of 3 over 2 pi n, where n is an integer. Thank you for watching and see you again.